discrete uniform. Okay, here is Excel table. I summarized Excel function procedures to simulate random variable for different distributions. For example, normal distributions. What we need is normal inverse function, a random generator, then information on the mean and standard deviation of this normal distribution. Very similar for the log normal distributions. Okay. For the discrete random variable, we use VLOOKUP, and we also have a random between. Okay. For exponential random variables, we will use here mu. Mu is the average times between the arrivals within a time unit. So let me first talk about two very commonly used Excel function. One is random. You have seen this already a lot, right? This is a common random generator we use a lot. Basically, create a number between 0 to 1. Random between the lower bound and the upper bound, where we create a random, but it's integer, like 20, 21, 22, 23, so on and so forth. Next, I'm going to move on and walk you through two examples. The first example is how to simulate a random variable for discrete probability functions. So for example, we have possible 5 outcomes. X could be 0, 1, 2, 3, 4. Imagine you have a bucket full of different balls, with different numbers from 0 to 4. But the chance you get hitting always draw a ball with number 1 is 35%. Draw a 0 ball is 20, 2 is 25, 3 is 15, 4 is 5%. So it's not equal probability. So this is the probability function, right? Now, so what we want to simulate long data sample. We want to see, imagine we want to simulate 1,000 balls. We want to see randomly, how likely we have a number x equal to 0, 1, 2, 3, 4. Okay, so first we want to create from PDF to Cdf accumulative density function. So how do we create the number? So what we do is we add up. Okay, so PDF is probability equal to x, but cumulative is a probability less than and equal to x. So what we do is first we add up. So x equal less than or equal to 0, so we start with 0.2. Then the probability we hit less than or equal to 1, so we will add the probability of hitting 0 and hitting 1, which is 0.2, 0.35, so it is 55%. So how likely we hit a value less than or equal to 2? So we will add up 0, 1, 2, the 3 probability, 0.2, 0.35, 0.25, which is 80%. So how likely we hit a number less than or equal to 3? 95%. How likely we hit 4 or below? That's all of the probability, 100%. So this is the upper bound of cumulative density function. So we also usually shift starting from 0, because we want to create a unique simulated result. So here, for example, use the first column and the last column value x. So if we simulate a number randomly between 0 and 0.2, say 0.1, so we will simulate x equal to 0. Suppose we simulate a number 0.4, so we will simulate our match value equal to 1. If it's between 55 and 80, match 2. Okay, 80 and 95, match 3, 95 and 1, 4. Okay, so you probably see this very similar to our VLOOKUP table indeed. So we will put them together as a VLOOKUP search table. Now we can use a random generator and the VLOOKUP and simulate the random x here, right here. We simulate 100 times. So that's the simulation data. After we have simulated data, we can look at the outcome. We can, for example, you want to look at based on 100 simulation. from the simulated data, what is simulated probability of hitting value equal to 0. So what we do is look at all outcome 100 simulation, and look at the value equal to 0, then divide the number trial, which is 100 repeats. So we got 23. And for value x, one of the simulation we got 34. So this is close but not identical. So when we simulate more and more large data, so the simulated probability more likely be closer to the assumed probability at the beginning. So this is a step of simulate a discrete random variable involves we create a CDF from PDF, then put them into a search table, then we simulate and look at the outcome. Another example I want to go over with you is a random variable following a normal distribution. The example I want to talk about is an investment strategy buy hold. Suppose you have $10,000 you put into S&P 500 market index, then you buy hold for 30 years. You want to check 30 years later how much money grow into. Then this index follow a normal distribution. The return follow normal distributions. So first of all, let's see. So here's the assumptions, right? So initial investment, target, and the mean standard deviation of normal distribution. Here for S&P, from those past data, historical data, the standard deviation is close to 20. So I put 10. So what we'll do is that first here we will list 30 years. Okay. So the return for the S&P 500 index annual returns, we will use norm invert, random, mean and standard deviation to simulate. Then we look at now money will grow from 10,000, right? We'll look at annual return. Okay, so on and so forth. Cumulative every year, the investment will go up or down, depends on the annual return simulated. So we will continue until 30 years later. Then we check what's the total investment grow into 30 years later. Now this is only one time, 30 years, one round. What we want to do is simulate like more time, like 100 times, 500 times, 1,000 times. So we will take advantage, use data table. There's a very special features. So what we do is here, for example, we listed the number 100 times. We listed a data table to the total investment 30 years later. Then we select a data output area. So what we do is data table, the column input cell, what we do is we link to an empty cell. So this is empty cell. Okay, so what does this? Every time we hit empty cell or hit F9, you kind of refresh your Excel. So Excel will automatically redo the simulation because random function will refresh it. So that it does is going to have a new simulate result. So it's going to copy down the new simulated result to the data table. So as you see, we do see a lot of variations. So after you simulate, for example, 100 times, so you have those simulated data. Now you can look at what's the mean of the simulated data. You can look at how likely you're going to hit your goal of $90,000, right? You use CONIF and look at 90,000 and divide by 100 simulated data time. So this example, we have 32. Moreover, you can also do the additional sensitivity of this probability of achieving this 90,000, especially the standard deviation. We may be the reality, the standard deviation could be larger. You can perform sensitivity against standard deviation, so on and so forth. So this is an introduction. As I mentioned, there's so much more to offer, but I want you to now move on to the practice in Excel.